we have to integrate the function 1 upon square root of sine cube x into sine of x plus alpha. Let's begin with the solution. And let I is equal to integral of 1 divided by square root of sine cube x into sine of x plus alpha into dx. So this can further be written as integral dx divided by square root of sine cube x into sine x plus alpha is sine x into cos alpha plus cos x into sine alpha, and this is further equal to integral of dx divided by square root of sine raised to the power 4x into cos alpha plus sine cube x into cos x into sine alpha. This is further equal to integral of dx divided by, now taking sine raised to the power 4x outside the root, this gives sine square x, and here we have cos alpha plus here we have cos x divided by sine x into sine alpha, since here we have taken sine square x outside the root, and this is equal to integral of 1 upon sine x is cosec x. So we have cosec square x divided by square root of cos alpha plus cot x into sine alpha into dx. Now let us suppose that t is equal to cos alpha plus cot x into sine alpha. On differentiating both sides with respect to x, we have on the left hand side dt upon dx. This term being the constant becomes 0, plus differentiating cot x with respect to x gives minus of cosec square x into sine alpha. This implies that minus of dt upon sine alpha is equal to cosec square x into dx. Therefore, this integral can further be written as integral of, in place of cosec square x dx we have minus of dt divided by sine alpha, and this we have supposed as t. So we have square root of t. Now this is equal to taking minus 1 upon sine alpha outside the integral since it is a constant. So we have dt upon square root of t, that is minus 1 upon sine alpha integral of t raised to the power minus half into dt, which can be written as minus 1 upon sine alpha on integrating t raised to the power minus half, we get t raised to the power minus half plus 1 divided by minus half plus 1 plus the constant. So this is equal to minus 1 upon sine alpha. This gives t raised to the power half, that is square root of t divided by half plus the constant. So this is equal to minus 2 upon sine alpha square root of t plus the constant. Now this is further equal to minus 2 upon sine alpha square root of t. T we have supposed as cos alpha plus cot x into sine alpha. So we have cos alpha plus cot x into sine alpha plus the constant. This is further equal to minus 2 divided by sine alpha into square root of cos alpha plus cot x is equal to cos x divided by sine x into sine alpha plus the constant. So this is equal to minus 2 upon sine alpha to square root of cos alpha into sin x plus cos x into sin alpha divided by sin x plus the constant. Now the numerator cos alpha into sin x plus cos x into sin alpha can be written as sin of alpha plus x divided by sin x plus the constant. Therefore, integral of 1 divided by square root of sin cube x into sin of x plus alpha into dx can be written as minus 2 upon sin alpha into square root of sin of x plus alpha divided by sin x plus the constant. This completes the solution.